Well, good afternoon, everybody, and thanks to this session, which is about market developments supporting digitization and delivering on net zero. So, quite an eclectic three pieces coming together. My name's Nigel Nawacki, and I work in Nokia. I'm responsible for the energy and the utility technology pursuits within the UK, Ireland, and also Europe. I was given the brief by the JRC to cover those three elements, and whilst they may look a little bit disparate, they actually come together to create some very interesting enablement. We're going to look at that across the next 20 minutes, and I hope what you will take away is the fundamental importance of a unified telecommunication environment that supports that journey towards net zero. I was given the briefing and I thought, well, why don't I just share my scratchpad? So when we look at that, there's three distinct areas. Market developments, well, okay, is that regulation or is that innovation from a driving perspective? The digitization, we all know that's about the future of telecommunications and particularly utility telecommunications, which have certain requirements that typically are not met through the more general communication service plays. And then we're going to look at some of the net zero and low carbon aspects of that. And one example of that is the renewables landscape. In the bottom corner there, you can see National Grid already cited that perhaps 65% of our generation will be localized, and very much back to the future kind of thought leadership there in terms of where generation started. And those of us that have a few grey hairs and are a bit long in the tooth may actually remember some of those distributed coal-fired power plants that we had across the cities. But we're coming back to that, distribution with a green ethos. So there's the scratchpad. What does it really mean in terms of a few of these things? And then not just thinking about it from a wireless perspective. I know the JRC predominantly has the wireless heritage. But what does fiber mean? What does it mean to increasingly build out distribution networks with fiber? Could that bring more broadband? What about the business models that result from that? So let's have a walk through and see where that gets us. As the landscape changes, what's really apparent is the new opportunities in business models. The network operators and the transmission operators are all starting to see the tension now in terms of how do you embrace the net zero, the low carbon landscapes. It puts tension on the infrastructure. Do I have the right comms to be able to connect grid supply points at an increasing pace and at different levels of the grid hierarchy? What are those generation systems, the things that are now putting electrons onto the edge of the grid, whereas before they were flowing from a centralized model? What are the complications in terms of power factors and frequency response systems that are required? If I'm a new entrant and we only have to look to Tesla, who now has a license within the UK to generate power, how do I transact? How do I make money from this new landscape? So you can see there's a healthy tension which gives rise challenges and new business opportunities. So net zero means new services then, if we kind of quickly distill that. And that could be through increased broadband build-out. That could be through some smart city ethos, where we can have market adjacencies. Obviously, low carbon means zero carbon in transportation, which will predominantly be electrified through batteries and through various systems. The increasing use of tramways and electric rail systems will no doubt be all over the landscape. So it's quite an interconnected environment if we project what net zero means. And that means more assets need to be connected, and that puts a heavier emphasis on the telecommunications value chain. But one thing to call out, has to be done securely as we increasingly couple generation and business models as part of our daily lives and the things we're going to get used to. Security is one of those key topics which has to permeate all of the assets, all of the connectivity in that new world. So what is government? What is the EU? What is the UK government really doing about this? Well, targets are being set. And when we look to some of the statistics that are out there, most countries are heading towards 50% renewable energy systems around 2030. There's different speeds and feeds given on the nation states, but generally there's an acceptance that we are moving towards high capacity renewable systems feeding into the grid. Now, what's interesting from this quick slide that we see here is this is not focused on the digitization. That piece of the puzzle is kind of missing. But if we look at the cost of generating electricity, generally it's stable between how it was predicted over the last decade and what it will cost into the new decades when we have renewables. There's a general understanding that the levelized cost, as they say, for the megawatt hours generally hovers around the same points. It doesn't shift too much. So that kind of tells us, well, if we're renewing some of the infrastructure and the costs are held leveled, then that should also apply to the administration of telecoms. It shouldn't be overtly expensive to follow the build out of the grid and to increase capacity from a telecom stance as well. I know there's not studies on that, but that's perhaps an interesting focus point. What is the cost of telecoms administration to support the new net zero utility grid? The good news is the industry's on that journey. 2019 was all about digitalization strategies for the modern energy grid, and that was called out by Ofgem. It's supported by the members there, the industry themselves, and it's given rise to a number of key innovations that will be some of the foundations within RIIO2. Active networks, being able to monitor and manage more, both at distribution and at transmission levels. Flexibility schemes, being able to administer power when it's needed and when it's not needed, giving benefits to heavy users if they're able to adopt the way that they consume kilowatt hours, megawatt hours. So having that flexibility in the networks is very key. But flexibility needs digitization. It needs more of a sensing neural grid kind of environment for it to be able to work. The point of this slide is really this capital investment coming from investment banks pushing low carbon systems, and we're also seeing through RIIO more of the incentivized investment for network operators and utility licensees to embrace low carbon strategies. The journey started. Generally, the trend looks good. We are moving towards increasing renewables. But the point of this is there's the missing dimension, and you can see it on the pie there. I've left it purposely out because often, as we joked at the beginning, we generally paint a cloud when it comes to utility telecoms. We don't really necessarily get into the nitty-gritty as much as we should do, in the same way when we talk about the low carbon landscapes and renewables. Comms is often the bit of the puzzle that's retrofitted, and we need to change that game. So transformation to net zero, what is it about this digital segment that's key? When we look over the past, having duty cycles, and that's kind of the latency and the way that telecommunications would work in the protocol levels, having duty cycles of a minute or two to connect and get some values back from the network was sufficient because things didn't really change that much. But as we move towards generation at distribution levels, now we need something which is sensing, and having interrogation cycles of 1 to 2 minutes probably isn't going to cut it for enabling that shift that we talked about. We will need a much more responsive system, and that's generally because the network's more volatile. If we have less rotating machines in terms of big rotating machines, and we're reliant on the wind, and we're reliant on solar, and we're reliant on batteries, then that grid is a lot more sensitive to disruption. And as a consequence, we need the telecom systems to be able to react and administer more capacity when it's needed, or even less capacity. Thinking about the summer where we had glorious sunshine, reasonable amounts of wind, although there was a lot of high pressure, and so we had good capacity in our renewable system. Not always the case, and certainly not guaranteed. So when we put it together, what that means is we need a telecom system which is dynamic, is able to provide capability for fast response, and is able to allow players to come together as a virtual power plant. And it's about keeping those lights on, because it's too easy to perhaps come back to some of the incidents we've seen over the last decade, where if you lose generation capacity, you have frequency issues, and those frequency issues can, if they go out of tolerance, give rise to the grid code effects, so the low frequency disconnects. And the reason I'm highlighting this is because low frequency disconnect, when you look at it, typically happens at the bulk supply levels, the 132 kV, the higher transformer levels. And that means large parts of heavy users are typically taken off the network so that the grid can recover based on generation and demand. And what's really needed when we look towards the smart grid and net zero is we have a lot more sensing and a lot more sensitivity on what we switch on and off to help the grid balance itself. And today we don't have that. The grid code has been there for quite a while. It does the job it's supposed to do. But that job is perhaps not the right one when it comes to administration of renewables over the next decade. So when it comes to operational systems, typically we look to SCADA systems to detect issues if we're doing teleprotection within the 10 milliseconds and lower, depending on the hierarchy, whether it's distribution or transmission level. We need to sense a lot more on the network. What is the quality of the power systems? So phase management, making sure there's no lags. And then if we're looking at, well, okay, if we need to increase generation or stabilize generation through different techniques, and there's flywheel technologies that have been looked at by the Power Networks Demonstration Center. There's capacitor banks. There's all kinds of things which come into play. Typically, we're looking at less than 1 second for the telecoms responses. But if we go back to the traditional SCADA systems, typically they can be operating within the minute to 3 minute marks in terms of how they poll and response. And that's just insufficient when we go forward on the landscape to look to charging stations, which are now starting to embrace standards-based protocols and open charge point type systems. We need the telecoms fabric, which can administer that. And going back to the problems that we had on August the 9th with the low frequency disconnect, again, and this was acknowledged from a Western Power distribution paper, the disconnects happen typically at the bulk supply points. But what needs to happen is that needs to move closer to the edge. But to do that, we need the telecoms fabric to also be in place to allow that more sensitive administration. So, is tradition really enough? Can we rely on existing telecom systems to bring together the net zero enablement? We can to a degree, because those systems are built for dependency, they're built for resilience, and they're built for being highly tolerant to a very large landscape. But are they sensitive enough? And that's perhaps where we get into some of the debate. Typically today, we see a lot of DMR, LMR radio systems, mainly predicated on narrow channel technology. So a kind of a one problem of sensing, one solution from a radio system. It's not typically multi-service per se. We see some sort of adjacent technologies like WiMAX, which are typically in sunset these days, a certain flavor of a radio system there. We also see microwave and point to multi-point systems used to be quite significant, but with regulatory shifts and a new horizon where we don't have the same spectrums anymore, what that tends to mean is we have silo radio systems, pinpoint solutions built out of the existing tradition. And if we think of that today, where we pick up a mobile phone and we get video, we get voice, and we get data, that's all converged on a unified platform. And it's very much the smartphone that we carry around. But if we did that with individual devices, we'd need very big pockets because we'd obviously need one for each. And that's just not the trend of the modern telecommunications fabric. So we shouldn't get despondent. These enablers that we seek to create that new fabric are there today. And they're predicated on standards from the 3GPP, which are now moving into the 5G specifications. That journey has started. There are new capacities and new capabilities that are coming out, but we don't lose sight of 4G. 4G has been used within the utility segment, and I'll come on to a few global examples of that in just a moment. And 4G as a starting foundation already takes you on that journey to 5G. It's just increasing the amount of compute and solutions that you need when the industry is ready to do that. And we already see a lot of discussions on digital substations and wireless digital substations, which set that scene. So specifically, what can you do with an environment that is proven, has been tested, and has a predictable nature? And that environment is the 4G LTE and 5G systems that were typically highlighted before. I'm not going to dismiss fiber totally, because fiber has a very significant role. But the key point here is Nokia and Bell Labs research have already conducted a number of proof points in this space, looking at a particular power utility use case, looking at the performance metrics, and then saying, well, yeah, we can meet that with the right engineering. We create a predictable fabric which can connect the smart grid with a number of use cases. And so we have already been doing this for well over a decade. And I'm saying a decade because 3G systems probably started the ball rolling on that with things like domestic metering. But now we're doing a lot more industrial control systems on top of LTE, because what we have created through private LTE spectrums is industrial wireless and a multi-service capability, which is very different to the silo radio systems we've seen previously. So the journey started. 5G takes us further and further towards mass connectivity. But today we're very much focused on the top part of the triangle, which is the 4G systems. So we're already rolling out 4G systems with a number of customers globally. And there's a couple of examples on that. As the standards evolve, you also get taken on that journey if you subscribe to a 3GPP system. So effectively, you will get increased capacity and features which are able to do more low latency and more industrial control systems as we move into the next decade of telecoms. Looking to the distribution network, we shouldn't be dismissive of using fixed fiber technology. The distribution network passes up and down our street, all the way from the street level transformer. So there's an ideal point of presence in which to create enabled fiber. Now, I know several business models have looked at that previously, and there's strong regulation around that. But the key point is, as we increase renewables at the grid edge, particularly microgrids and even domestic ability to go on and off grid, we're going to need increasing sensing. And that could be administered through optical network technology with devices up and down the street, able to connect to the various sensing points. Typically, though, what we would see is that would be done through a wireless enablement. And this is where we've seen a lot of distribution automation, typically in the US, converging a number of radio systems, siloed radio systems, onto a multi-service fabric, which is essentially fourth generation LTE. Some people today call that 4.9G. That's been done, and there's been a number of utilities who have embarked on using wireless technology to enable that increasing sensing. And I think the reality is it's a mix of both. You need fiber at the edge to be able to provide for the new radio antenna systems, the distributed radio access networks. So it's a complement. Fiber is equally important to that net zero as is wireless in the big equation. So who are those customers? Nokia have done significant amounts of work in the US. We're just highlighting a very significant US utility there, which predominantly wanted to converge a number of those siloed radio systems. They did not want the overheads of operating legacy radio systems in the field. So a number of proof points were put together to basically create the capability where an LTE system could underpin very significant use cases for interrupter switching, for sensing, for AMI, and basically improving the SCADA system onto a single multi-service fabric. Similarly, here in Europe, we've seen utilities embracing 450 megahertz to improve communication capabilities. So push to talk, push to video is now very much part of an aspiration we see in Europe across a number of countries where such licensing has been facilitated by the regulators. We also see in Brazil, moving to Latin America, through one of the operation companies in Iberdrola, the use of LTE for concentration, being able to pull back hundreds of thousands of smart meters across an IoT-based environment, but they're very much using LTE to connect large amounts of the landscape with a view to domestic metering. And I guess these 3 points in itself really demonstrate that multi-service capability that you get from 3GPP systems. I'm working with the JRC. We're seeing a lot more discussions on the renewables and the offshore wind farm segments, where, again, LTE is used to help coordinate the crews in terms of being able to do maintenance and to do crew communications from the service operating vessels. So what we're seeing there is a lot of discussion on how the offshore substation can be enabled with LTE systems, which then provide very significant operational benefits for the stakeholders. And the example there at the bottom, if anybody is interested, is a replay of some of the Nokia solution that went into place for one of the offshore systems there in the North Sea. So bringing it together, whose job is it? Is it the vendor? Is it the JRC? Or is it trade and alliance associations? Well, actually, tongue-in-cheek, I did pull out a little bit of a slide from our government recently. Actually, it's about building it together, because we, as a vendor, as Nokia, work very closely with the industry, and we very much value the feedback of the trade associations. And the reason for that is we can't just make products without meeting the expectations. Utilities need communications infrastructure that is proven, that is assured, that is secure. We need to source from the global stage proven electronics from a value chain point of view. And we can only do that when we can address a marketplace. We can't build niche systems. We have to work to standards. So we very much do value the work that we see with the JRC, with the UTC, and with the EUTC, all driving standards like 3GPP. And I think, and I firmly believe, it's not a dream. That is the only way we will achieve net zero. So I hope you found that useful. I'll be joining the panel session later and would be very pleased to take any of your questions. Thank you very much.